Hello, here is today's warm-up. So this is similar to a question that you would have seen yesterday, so why don't you pause the video and give this a shot. All right, you ready to see the answer? Okay, so first step is we got to figure out what quadrant this is actually in. So it says cotangent is less than 0, so that means negative. And if cotangent's negative, what other trig function would also be negative? Tangent. So tangent is negative, and they're telling you that sine is equal to radical 7 over 3. So they're telling you that sine is positive. So the first step is to use all students tried cheating. And if tangent's negative, well, tangent's positive here. So if it's not positive, it's negative. That's over here. And sine is positive. That's all an S. So we're in quadrant 2. So first step is to draw a triangle in quadrant 2. How are we going to label that? Sine is opposite over hypotenuse, so the opposite is radical 7. The hypotenuse is 3. And then we got to find the other side by Pythagorean theorem. So a squared plus radical 7 squared equals 3 squared, which means a squared plus 7 equals 9. So a squared is 2. When you take the square root of that, we get radical 2. But remember, a radical, when you take a square root, you get plus or minus. Which one is this? It's minus. It's going to the left. So negative radical 2. Okay, they want you to find cosine of alpha in simplest radical form. Oops. So cosine of alpha. Cosine's always adjacent over hypotenuse. And the adjacent side would be negative radical 2, and the hypotenuse would be 3. So negative radical 2 over 3. All right. See a random fact. There are 1 million ants to every human in the world. True story. Okay, next up, let's talk about homework. So this was last night's homework, and actually this is tonight's homework. Let me grab last night's real quick. All right, here we go. And the two problems I want to really go over are, first one if you had trouble with was number 3. Given that theta is 6 pi over 5, which the following statements about theta is true. All right, well, if you're 6 pi over 5, oops, what quadrant are you in? Quadrant 3. Because here's 0, pi over 2, pi, if you're over 5, this would be like 5 pi over 5, so 6 pi over 5 is 1 more than it. So you're in quadrant 3. All right, so if you're in quadrant 3, and you know this is all students try cheating, let's see which one's true. Is cosine negative? Well, if I'm here, yes, cosine is negative. Is sine positive? Nope. So that's out. Is tangent positive? Yep, because that's t. But if tangent's positive, so is cotangent, so that one's definitely out. Cosecant, what's that related to? Sine. So would sine be negative? Yes, it would. Secant is related to cosine. Would cosine be positive? No, it would not. So hopefully 4 works. Tangent's positive, true. Secant, which again is cosine, would be negative. So that's why it's 4. So you're in quadrant 3. Tangent's positive because that's the t quadrant. And since secant's related to cosine, cosine's only positive in 1 and 4, so it'd be negative over here. Okay, so that's why number 3 is choice 4. Then over on the back, the one that I saw give the most trouble was number 6. If secant is greater than 0. So if secant's greater than 0, what else is that telling you? It's telling you that since secant's 1 over cosine, cosine is also greater than 0. And sine is equal to a negative. Okay, so cosine is positive, sine is negative. All students try cheating. Cosine positive, all in cosine. Sine is negative, so not S and A, so the other two. Put you in quadrant 4. Most of you got that, okay? And then opposite over hypotenuse. Make the side negative that you know should be. This is negative radical 3. The hypotenuse is over here. That's 3. So we want to find our other side. So a squared plus negative radical 3 squared equals 3 squared. Now, a mistake I keep seeing is not putting parentheses around this piece. Remember, anytime you square a negative, it becomes positive. So this would really be a squared plus 3, because radical 3 squared is 3, but the negative goes away, equals 9. A squared is 6. Take the square root. So a equals plus or minus radical 6. But if you're going to the right, you're going to be positive. So that's where the radical 6 comes from. And then finally, if I want to find cosine of alpha, which is adjacent over hypotenuse, the adjacent side, we're always talking about from the reference angle, is radical 6. Hypotenuse is 3. Okay, so hopefully the rest of the homework went okay. If you have more questions, ask me. And let's go to today's notes. Today's notes are all about something called the Pythagorean identities. But first, we've got example 1, which is kind of a holdover from yesterday's stuff. If the terminal side of angle theta in standard position passes through the point negative 3, 2, what is the numerical value of cosecant of theta? Well, anytime they ask you to find one of these trig functions, you draw a picture. That should always be your first thought. If I need to evaluate a trig function, I need a picture. Terminal side, you've seen that before. What does that mean? Basically, it means where the angle ends. So the angle ends in quadrant 2 because it passes through the point negative 3, 2. So if the terminal side goes through that point right there, you're in quadrant 2. And the easiest way to draw a picture then would be to draw a picture straight from that point. So you know this is negative 3, and we went up 2. So now it's just like yesterday. Now I can fill in everything I need. Negative 3 squared, notice that's in parentheses, plus 2 squared equals c squared. That's 9 plus 4 equals c squared. Negative always goes away when you square it. So c is plus or minus radical 13. What's this one going to be? Plus, because it's the hypotenuse. All right, so cosecant of theta. Remember, that's 1 over sine of theta. So since sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. So hypotenuse is radical 13, opposite is 2, radical 13 over 2. And there you have it. Okay, now you'll notice in that example, the Pythagorean theorem played an important role in determining the solution, and that was most of what we did yesterday. You had to use Pythag on that triangle at some point to get your third side. So there's another trigonometric identity that comes from the Pythagorean theorem, which is why it's called the Pythagorean identity. And you'll notice I wrote identities because there's more than one of them, but this year we're only going to really focus on one. So let me show you where this comes from. So consider an arbitrary angle theta intersects a circle with a radius r, so I'm going to call this r here, at the point xy. So similar to what we just did, if that's xy, I can draw a triangle, a right triangle. What would this distance down here be? Think of that point. We went over x, up y. So this is x, this is y. You've seen this picture before. And what we know based off of this picture, we know that sine of theta equals what on this picture? Opposite is y, hypotenuse is r, so y over r. And we know cosine of theta is adjacent over hypotenuse, so that's x over r. Remember, this is how we developed quadrantals. If we're on the unit circle, if r was 1, this would just be y over 1 or y. Cosine would be x. And we know tangent of theta is y over x. opposite over adjacent. Now we also know if I did sine of theta divided by cosine of theta, using this picture, we'd get y over r divided by x over r, which is a complex fraction that simplifies pretty easily if we multiply top and bottom by r. R's cancel, and I have y over x. Now, why is that important? Because I just got that tangent of theta equals y over x, and sine of theta over cosine of theta also equals y over x. That's where that identity that we've seen before came from. Since those both equal the exact same thing for any theta, that means tangent of theta equals sine of theta over cosine of theta. So it's kind of just like we're doing substitution. If this equals y over x and this equals y over x, then they have to equal each other. Now it's an identity. We've talked about identities versus equations. Identities have to be true for every variable. And my variables here are x and y, but also theta. So theta is some random angle that I drew. I could have drawn any theta that I wanted anywhere, and we would have had a similar picture, and we'd get the same result. So this is an identity because it works for any angle theta. Okay, so that's one identity. But I can also say, we haven't really talked about this one too much, but since cotangent of theta is the reciprocal of tangent, what do you think cotangent of theta equals? We've already seen it as x over y when you're doing quadrantals, but tangent sine over cosine, cotangent is cosine over sine. Cosine of theta over sine of theta. So that's technically another identity. It's always true. And those are obviously pretty similar. I remember it with cotangent starts with c, and that's one with this c trig function on top, cosine, c. That helps. Okay, now there's one more big one. These aren't technically the Pythagorean identities. These are called the quotient identities because they're fractions. On this picture, one side note, by Pythagorean theorem, what's x squared plus y squared going to equal on that picture? A squared plus b squared equals c squared, so x squared plus y squared equals, right, r squared. Now let me show you something else. Let's say I wanted to evaluate sine squared theta plus cosine squared theta. Again, this is for any angle theta. I'm really just using that picture. We've already said sine theta is y over r, and cosine of theta is x over r. So sine squared theta is, y over r squared plus cosine squared of theta. Cosine again is x over r squared. Now you might think that looks a little weird. Don't write this part down. All I'm doing is I'm taking sine of theta and squaring it. They don't write it like this because then it's hard to tell, okay, well, is theta squared or is this whole thing squared? And you could just put parentheses around it. But just know that that means they put the squared on the sign. It's just kind of a notation thing to show you that it's the whole function being squared and not just that angle. Okay? All right. Back to this. So if I'm squaring y and r and x and r, square the top, you get y squared. Square the bottom, you get r squared. Over here, square the top, you get x squared. Square the bottom, you get r squared. So you got fractions. But these fractions have common denominators, so what can I do with them? I can add them together. Y squared plus x squared all over r squared. But then go back to this. What's y squared plus x squared equal? R squared, right? So this is really just equal to r squared over r squared. And r squared over r squared is always 1. So the final new identity that we're going to do this year is that sine squared of theta plus cosine squared of theta always equals 1, no matter what the angle is. And that's the Pythagorean identity because the Pythagorean theorem played a big part in it. Now there are other ones we can get using tangents and secants and cosecants and cotangents, but you'll do those next year. Okay, so I'm going to flip the page. We'll do some examples. So in this box, I'm just going to put that identity again. Sine squared theta plus cosine squared theta equals 1. And what I keep saying is we didn't specify the value of theta. It could have been any angle on that picture. This is an identity as opposed to an equation. This is true for all values of theta. So example, if I pick a random value of theta, let's say theta is 32 degrees. Okay, well then for sure, sine squared of 32 degrees plus cosine squared of 32 degrees has to equal 1. And I'll prove it to you. What mode am I in? Degree. Okay, great. So if I want to do sine squared on the calculator, you have to do it with parentheses. You have to do sine of 32 parentheses squared. So sine of 32 degrees squared plus cosine of 32 degrees squared. Again, notice my parentheses, so the whole thing is squared. Equals 1. And that was just a random number I picked. Any angle you pick is going to always equal 1 because I proved it with that picture. All right, using these identities along with our knowledge of trig functions, we can answer these questions. Here's the warm-up again. Now, if you remember the warm-up, do I still have it up? Yep. Exact same question. I drew my picture, used Pythagorean theorem to get the other side, and then did SOHCAHTOA. You can always do that. That's fine. Here's another option. So you still have to figure out what quadrant you're in. If it's known that cotangent is less than 0, so again, that means that tangent is negative, and that sine of theta is radical 7 over 3. So we know that sine is positive. Determine the value of cosine of theta, or alpha, in simplest radical form. So you still have to do all students try cheating. You need that. Okay, so tangent's negative, not a and t. Sine is positive, a and s. You're in quadrant 2. Now instead of drawing a picture, I'm going to use this identity because I have sine and I want to find cosine. So it's alpha this time. So I'm going to say sine squared alpha plus cosine squared alpha equals 1. Plug in what you know. We know sine is radical 7 over 3. So radical 7 over 3 squared plus cosine squared alpha equals 1. My goal is to find cosine of alpha. So what would radical 7 over 3 squared be? We'd square the radical 7 and you'd get 7. Square the 3, you'd get 9. So 7/9 plus cosine squared alpha equals 1. You subtract the 7/9. What is 1 minus 7/9? Think of this as 9/9. So 9/9 minus 7/9, 2/9. Take the square root. And we get cosine of alpha equals, what happens when you take a square root? Plus or minus radical 2, because that's not a nice radical. But what's it going to be over? Radical 9 is just 3. You know, compare that to the warm-up. That's close. The answer is negative radical 2 over 3. Right now we've got plus or minus radical 2 over 3. That's where this plays in. If I'm in quadrant 2 and I'm looking for cosine, is cosine positive or negative in quadrant 2? It's negative because cosine is only positive in 1 and 4. So over here we're negative. So this tells me that my answer is negative. So it's negative radical 2 over 3. So if you ever see an example that doesn't specify or that says using the Pythagorean identity, this is how you'd have to do it. Kind of annoying. I like the picture way better, but you can obviously see you can do both. Here you avoid drawing a picture, but you have to remember this still. Okay, let me show you this. So given that cosine is a random number like 0.198, they tell you that theta is between 3 pi over 2 and 2 pi. So what's that trying to tell you? Well, think about what that means. 3 pi over 2 is down here. 2 pi is here. So if I'm between that, I'm in quadrant 4. So this is just telling me quadrant 4. Find sine of theta to the nearest thousandth. If we used a picture like yesterday, I already know the quadrant I'm in. So draw your triangle. 0.198 might look weird, but you can think of that as over 1. So adjacent is 0.198. Hypotenuse is 1. I'm going to need this side. How am I going to get it? Pythag. So 0.198 squared plus b squared equals 1 squared. Here I'm definitely going to need my calculator. So 0.198 squared is that number, 0.039204. Don't round till the end. Plus b squared equals 1. I got to subtract 1 from that. So 1 minus that answer gives me 0.960796. And that's b squared right now. So take the square root. So square root of that answer. Okay, to the nearest thousandth, so 0.981. But remember, it's plus or minus. And you just have to figure out that since I'm going down, it's going to be negative. Negative 0.981. Okay, so finally, after all of that, we want to find sine of theta. Sine of theta, opposite over hypotenuse. The opposite side is negative 0.981. The hypotenuse is 1, so negative 0.981. Okay, that's pretty much doing yesterday with maybe just a little bit uglier looking. All good? Oh, I don't know why I said 981. That's 980. Sorry. Okay. Now using the identity. Now again, think about what identity to use. I have cosine, I need sine. So it's the Pythagorean identity that relates those two. So I would just say sine squared theta plus cosine squared theta equals 1. Plug in what you know. So sine squared theta plus 0.198 squared equals 1. And you're going to see pretty much you get the same formula we just did. I've got to do that 0.198 squared again, which becomes 0.039204. So sine squared theta plus that equals 1. Now subtract the 1, again, which we've done. 1 minus that is the 0.960796 number. Equals sine squared theta. And I take the square root. So sine of theta equals, we already know that's that plus or minus 0.980. And since we're in quadrant 4, which all students tried cheating, that means that sine is negative, so negative 0.980. So you can see why the Pythagorean theorem is closely related here. It's basically the same equation if I look here and you look here. The advantage to the picture is you can look at the picture to figure out if sides should be positive or negative. The advantage to identity is you don't have to draw the picture, so maybe a little bit quicker, but you have to know what quadrant you're in and what your trig function in that quadrant should be, positive or negative. Okay, here's another one. An angle theta has a terminal ray that falls in the first quadrant. Cosine of theta is 1/3. Determine sine in simplest radical form using a picture. This is like yesterday. What am I going to draw? Well, it told us quadrant 1. And it told us that adjacent is 1 and hypotenuse is 3. So 1/3. Next step, Pythag. 1 squared plus b squared equals 3 squared. 1 plus b squared equals 9. B squared is 8 when I take the square root. Carefully, you need simplest radical form, so don't leave it as radical 8. What would that be? B would equal plus or minus, 8 is 4 times 2, so plus or minus 2 radical 2. But since I'm going up, it's positive. So if I want sine of theta, opposite over hypotenuse, the opposite is 2 radical 2 over the hypotenuse of 3. And there we have it. Using the identity, again, I have cosine, I want sine. So the identity that relates those, sine squared theta plus cosine squared theta equals 1. Plug in what you know. You know cosine of theta is 1/3. So sine squared theta plus 1/3 squared equals 1. Sine squared theta plus 1/9 equals 1. You could use your calculator if you want, but what's 1 minus 1/9? 9/9 minus 1/9 is 8/9. Take the square root, and you get sine of theta is equal to the square root of 8, which again is 2 radical 2, over the square root of 9, which is 3, plus or minus because we took a square root. But since I'm in quadrant 1, and all the trig functions are positive in quadrant 1, you know the answer is positive 2 radical 2 over 3. Okay? 2 different ways. Pick your favorite. All right, last page. It's known that cosecant of theta is less than 0, and cosine of beta is positive 5/8. We want to determine tangent of beta in simplest radical form. So regardless of what I do, I have to use all students try cheating this time, because I don't know what quadrant I'm in. Cosecant less than 0 means what else is less than 0? Sine. So sine is negative. So not A and S. So down there. Cosine's positive. So I'm in quadrant 4. Using a picture, I label adjacent as 5 and hypotenuse as 8. Next up we would Pythag. 5 squared plus b squared equals 8 squared. 25 plus b squared equals 64. If you subtract 64 minus 25, you get 39. Take the square root. B is plus or minus radical 39, but I'm going down, so it's negative radical 39. We want to find tangent of beta. Opposite over adjacent. Opposite's negative radical 39, adjacent's 5. And that's already simplest radical form because nothing goes into radical 39. Okay, now if I want tangent using an identity, what's the only identity I know involving tangent, right now at least? Well, I know tangent of beta is sine of beta over cosine of beta. And I know cosine of beta is 5/3. And if I hadn't done any of this over here, I wouldn't know sine yet. So if I'm strictly using an identity, I'm going to start by using sine squared theta plus cosine squared theta equals 1 to figure out sine. Okay, so I've got sine squared theta plus cosine, so 5/8 squared equals 1. Sine squared theta plus 25/64 equals 1. Subtract 25/64. Sine squared theta equals 1 minus that. 64/64 minus 25/64 would be 39/64. Take the square root, and I get sine of theta equals plus or minus radical 39/8, which you can see on your picture is right. And since I'm in quadrant 4, sine would be negative. But that's not my answer. Now I've got to use that over here in tangent of beta. So after all that, now I know that tangent of beta, which is what I want to find, is sine. And I used thetas here, but I guess technically these should have all been betas, no big deal. Tangent of beta is sine of beta, which is negative radical 39/8, over cosine of beta, which was 5/8. Complex fraction, but if you multiply top and bottom by 8, we get negative radical 39/5. So which way do you think is easier here? I would probably go towards the picture. Generally, use the picture. The identity is going to have a lot of more applications in pre-calc and calculus and math 12, but when you're finding evaluating trig functions, drawing a picture is really the way to go. So the last one, they don't specify what you need to do, given that tangent of theta is negative 0.9366, tells you where theta is. Find the value of cosine of theta to the nearest thousandth. It would definitely be easier to draw a picture here. So if it doesn't specify picture or identity, and it just leaves it up to you, you can pick your favorite. I usually go with picture. What quadrant is this going to be in? Quadrant 2, because here's pi over 2, here's pi. I'm between there. They tell me that tangent is negative 9.366. So opposite over adjacent. Opposite, now is opposite going to be negative? No, you got to be smart about your negatives because that's going up. The adjacent must be the negative one. Okay, so then Pythag it. 9.366 squared plus negative 1 squared equals c squared. Let's type in this whole left side in one step. 9.366 squared plus negative 1 squared, but that's just 1. Hopefully you know that. That's equal to 88.721956 equals c squared. Take your square root. Square root of that. 9 point nearest thousandth, so 9.419 equals c, plus or minus though, but since it's the hypotenuse, it's def, plus, so 9.419. They want me to find cosine of theta. So cosine of theta, which is adjacent over hypotenuse to the nearest thousandth, would be negative 1 over 9.419. Make that to the nearest thousandth by putting it in the calculator. And our answer is negative 0.106. Okay, that's it. So the biggest takeaway from the day, picture I think is easier. The only time I would use the identity to evaluate is if the direction specifically said using an identity. That's all I got. Good luck on the homework. Let me know if you got questions.